Okay, guys, welcome to Scientific Notation. We're actually right now going back to Chapter 4. This is 4.7 in Chapter 4. Okay, so we're going to kind of skip around the rest of the year. There's several topics that I want to teach you, make sure you know by the end of the year. And this topic, scientific notation, is really used more in your science class than in your math class. And it's used to write numbers that are really big or really small, just an easier way to compare them, to look at them. Okay? So we know a number is in scientific notation if it's in this form, right here. So some number C multiplied by some power of 10. Okay? And it's important to notice that C has to be a number that's greater than or equal to 1, but less than 10. Okay? So that's the deal with C, greater than or equal to 1, but less than 10. And n, which is the exponent, is an integer. Okay? It could be negative or positive. All right, so let's see how it works. We're told something about the human eye here, that the retina is about 0.00012 meters thick. So we want to turn that into a number C, which is between 1 and 10, times some power of 10. Okay, so let's write it over here. So can you find the number in this number that's between 1 and 10? Can you see how you'd move the decimal place till you get to a number that's between 1 and 10? So what you need to do, and I'll use a different color, black, is you need to go 1, 2, 3, 4 places over. Okay? So we've got our number C, 1.2, okay, because I just moved the decimal point over to there. And then we're going to multiply by some power of 10. Now, to know whether the exponent is negative or positive, look at your original number. If it's less than 1, your exponent has to be negative, okay? And since we went 1, 2, 3, 4, 5 places with the decimal, our number is negative 5. Okay? So down here in green, if our original number is less than 1, our exponent's negative. If our original number is greater than 1, the exponent will be positive. Let's look at the next one. The human retina contains 120 million rods. So let's write that down. Whoops, I got the thicker marker on mistake. 120 million rods. All right, can you see where the decimal place is now? If you're thinking it's at the very end, you're absolutely right. So we've got a decimal place at the end here. Now we have to move it left until we get to a number that's between 1 and 10. So it's going to be 1.2 again, isn't it? So we got 1, 2, 3, 4, 5, 6, 7, 8 places until we get there. So we've got 1.2 times 10 to the 8th. Is it 10 to the positive 8 or 10 to the negative 8? Well, since our original number is more than 1, our exponent is going to be positive. Okay? All right, last one. The human retina has 6 million cones. I don't even know what cones are, but maybe you do, taking biology. Okay, and these are commas. So here's 6 million. Again, the decimal place is at the very end here. So we're going to have to move it until we get to that number between 1 and 10. Okay, so can you see what that number is? 1, 2, 3, 4, 5, 6 places, and there we go. We've got a number between 1 and 10, 6.0. So we're going to write this as 6.0 times, how many places did we go? 1, 2, 3, 4, 5, 6 places. And since our number was bigger than 10, bigger than 1, it's a positive 6. What do you think? Think you're getting it? Okay, the next thing we want to do is to go the other way. We want to write 7.5 times 10 to the 6th in standard form. Okay? Well, the positive exponent tells us we're going to move to the right. We're going to move the decimal point to the right. Okay? And then on the next example, since this is negative, we move to the left. So that's the first thing to notice. Is the exponent positive or negative? All right, so we take our 7.5, let's write it over here, and we have to move the decimal point 6 places to the right. Well, that means we're going to have to add a bunch of zeros. Can you see how we're going to have to add 5 zeros? Okay, so let's do it. So 1, 2, 3, 4, 5. Now we can move the decimal point 6 places. 1, 2, 3, 4, 5, 6. And there we go. So our number is going to be, I'll stick my commas in here, our number is going to be 7,500,000. Okay? All right, let's try the next one, 1.45. Okay, so I'm going to write it over here, 1.45. My exponent is negative. I know I'm going to have to move to the left. Okay, I have to move to the left 4 places. Well, if I move to the left once, okay, I'm going to need to go 3 more times, which means I need to add 3 zeros. And an easy way to remember it is the number of zeros that you need to add is always going to be 1 less than the exponent. Okay, so I'm going to move this 4 places to the left. Okay, and my answer is going to, and I'm going to stick a 0 over here just as a placeholder. It makes it easier to see the decimal. Okay, let's just think backwards for a second. If we were going to take this number and put it in standard notation, right, we would go 1, 2, 3, 4 places to get to 1.45, right? And then we'd have to multiply by 10 to the negative 4. So we would get back to that. Okay, hope you're getting it, guys. All right. Last kind of problem is ordering numbers, comparing them to tell which is the smallest and which is the biggest. So we have this number in scientific notation, this number which is in standard form, not in scientific notation, and this number in scientific notation. Well, it's easier to see that the last number is smaller than the first number because the first number you're going to have 5 zeros, the last number you're only going to have 4. Well, what about the middle number? Well, we should probably put that in scientific notation so that we can compare it. So the decimal place is right now at the end here. We're going to go 1, 2, 3, 4, 5, 6. So we'll get to 3.8 times 10 to the 6. Okay, so now we can compare our numbers. We've got them all 3 in standard notation, scientific notation. So which one's the smallest, would you say? Well, it's still the third one because it has the smallest power of 10. So we're going to write 4.2 times 10 to the 5th is first. And then which is next? Which is smaller, 3.8 times 10 to the 6th or 3.9 times 10 to the 6th? Well, if you're thinking it's the 3.8, you're absolutely correct. But let's write it in the form it was originally given to us. So we'll write it as 3,800,000. And then our last one is 3.9 times 10 to the 6th. Okay? All right. I hope you'll be able to do 1 through 12 at this point, and I will look forward to seeing you tomorrow. Thanks for watching.